Hey, in this video, we're going to talk about absolute value equations and inequalities. We just do a little bit with this. Mostly we graph them, which I think you've had some exposure to, but we'll look at that in a second video. So for this first part here, I just wanted to define absolute value equations and inequalities. Definition: a number's absolute value is its distance from zero on a number line. So for example, if you have absolute value of 3 like we have here, the result would be 3. And if you have negative 3, that would be 3 jumps to the left on a number line, but we're just looking at distance, which is always going to be a non-negative. And then absolute value of x. So how do we assess that? We'd have to say, well, that x could actually be, like, say, for instance, a -2, or it could be, a +2 or something like that. So we have to consider the different situations we would have. So if we had something like absolute value of x equals 2, how do we deal with that? We have to set it up like this. We have 2 solutions, really, 2 possibilities. So in this case, I just want to clarify here, this is just straight up number. If I have absolute value of 3 is 3, absolute value of -3 is 3. But here, where I have a variable inside here, I have to figure out what that would be. So I'm making up an example here. If I had absolute value of x equals 2, I would have 2 solutions. So I would set it up as x equals 2, and both have to be true, so I have to use an and, x equals -2. Okay, so there's really nothing, to really solve there. I'm just writing it out. So if I were to write that in set notation, I would write it as -2, 2. So however order that works out, we want to put it in numerical order here, just to be consistent. So now I'm going to look at the principle for equations, absolute value principle for equation. For any positive number c in any algebraic expression x, the solutions of absolute value of x equals c are those numbers that satisfy x equals -c or x equals c. So kind of just what we did over here. The equation absolute value of x equals 0 is equivalent to the equation x equals 0. The equation absolute value of x equals -c has no solution. We would never come out with anything with a negative distance from 0. So the steps to solve, we're going to first have to isolate our absolute value. We're going to set up and solve 2 equations based upon the absolute value principle that we looked at up here. And then we're going to check our answers. That's really important, just to make sure there's not a weird glitch of some sort. Or you'll see where like a number 2 is going to come out a little odd if you didn't catch something to begin with, but hopefully you will. So now, just like when we have radicals, we have to isolate the radical. Just like when we have something squared, we wanted to get that by itself on one side first. So here we have our absolute value of 2x plus 3. So that's what we want to isolate. So we're going to add 3 to both sides first. To be really careful and make sure we don't forget to do that step. So then we end up with 2x plus 3 in absolute value symbols, just straight lines, equals 9. So then once we have that set up, now we can write our different scenarios. So using the absolute value principle that we talked about, we would have what's inside the absolute value without the symbols. And we would have equals, I'm going to put the -9 first, -9. And we also are going to have 2x plus 3 equals 9. So those are my two different scenarios or situations that I have. So now I can go ahead and solve. So I'm going to subtract 3 from both sides here, and I will get 2x equals negative 12, x equals negative 6. And don't forget to bring that down, because that's really important. We have an intersection that's going to be happening here. Where both of these need to be true, is what we could say. It's not an inequality in there. We're going to have to really even, gets a little messier. So we subtract 3 on this one. We get 2x equals 6, x equals 3. And then we would write our answer. I'm going to write it over here in set notation, negative 6 and 3. Okay, so that is all there is to that one. For number 2, you might notice right away that we have absolute value of x plus 1 equals negative 2. And from what we saw up here with our principle, we should know right away no solution. So you can actually simply just go ahead and write that. But you can see why that wouldn't work. Like if you say you didn't notice it, and you went through the process and you were solving stuff in the check, it wouldn't work. Like say for instance, this would be wrong, but I just want to show you why that wouldn't work out. So if I just said x plus 1 equals negative 2 and x plus 1 equals 2, like say you just didn't notice what was happening, you would end up getting x equals negative 3 and x equals 1. But if you went to plug those back in up here, you're going to have a problem, because you're going to have, let me just do an orange one there. We would have, say I pick the negative 3, absolute value, negative 3 plus 1 equals negative 2 is what it tells me the rule is here for my function. But when I go ahead and do that, I'm going to get negative 2 in absolute value symbols equals negative 2. And that is not true. It doesn't work. So there's no solution. Same would happen for 1. You're going to get 2 equals negative 2. Well, that's not true. So you can't ever set this when it's equal to a negative, just write no solution. Do make sure that your absolute value is, the expression is isolated first though, because it might kind of seem that way, but if you do an operation to one, to the other side, then you might clear it up and get rid of that negative. So always just focus on that isolating first. Okay, now on this one we have 2 times, so there's not going to be a parenthesis or operation symbol. It's just that those straight lines, they also notate multiplying. So we have 2 times absolute value 4x minus 2 plus 4 equals 12. So first thing I'm going to do is subtract 4 from both sides. And then I'm going to get 2 times absolute value 4x minus 2 equals 8. And then I want to divide both sides by 2. And I get 4x minus 2 absolute value equals 4. Now I'm ready to go ahead and split this apart and make my 2 scenarios. This is a positive 4 here that I ended up with even after I isolated. So 4x minus 2 equals 4, and 4x minus 2 equals negative 4. Doesn't really matter which one you have on the right or the left or what have you. So we can go ahead and solve now. So we have I'm going to add 2 to both sides here, and I get 4x equals 6. And so x equals 6 over 4, which would be 3 halves. And now on this other one, 4x minus 2 equals negative 4, I'm going to add 2 to both sides. 4x equals negative 2. Divide both sides by 4. I get x equals negative 2 over 4, which would be negative half. So if I write my answer in set notation there, then I would write it with the brace, negative half, comma, 3 halves in the brace. Then I would want to check my solution by plugging each one back in and just making sure I actually got 12. So I'll just do one of them. If I plugged in negative 1/2 up here, I'm just going to get rid of this. So if I put in negative 1/2, so this is my check, I would have 2 times 4 times negative 1/2 minus 2 absolute value plus 4 equals 12. So I'm saying, does that equal? Let's find out. So I'm going to simplify inside first, inside my absolute value. So I end up with 2 absolute value, and just reduced that out to be 2 with a negative. Don't forget that negative. So this is going to be negative 2 minus 2 absolute value plus 4 equals 12. Then I have 2 absolute value of negative 4 would give me positive 4. Now at this point I'm going to make it be like in parentheses to notate multiplication. Plus 4 equals 12. Is that true? 8 plus 4, yes, that does equal 12. So negative 1/2 works. And you would do the same process with the other number. Just verify and make sure it's correct. You don't have to do that usually every single problem, but you want to do it enough. Now here is number 4. Try this one for your own classwork. So pause the video and go ahead and do that. And then we're going to look at graphing in Desmos. You could just plot it using transformation. Well, you don't have transformations yet, but you could just plot it by putting picking values for x and finding the y values and looking at, you know, where the solution lies on there. You would graph this, and then you would graph the constant function 11. That's what we're going to do in Desmos, and see if your answer is true. So I'll walk you through all that too. So go ahead and pause. I'm going to write up the solution here and then talk through it really quickly, but I'll see you back in a few minutes. Okay, so your answer comes out to be negative 2 and 3. Are the values for x. So what you have to do here is I isolated my absolute value. I ended up with negative 2x plus 1 inside the absolute values, so that equal to 5. So then I just wrote out my 2 scenarios, solved down, got negative 2 and 3. So now I'm going to show you in Desmos. Let me find my Desmos. So this is a free website. I've posted this before and showed you this before, but I'm going to show you how to type in using their pad here. So it will often be closed like this, and this for my Surface, this is my own Surface thing that pops up, but I probably don't want to use that. I'm going to use the Desmos one. So I'm going to click that keypad to come up, and I want to type in my absolute value function. So it was 3, and then we have this absolute value symbol here. So we're going to go ahead and type that. It'll give us the first line, and then we have to put in the negative 2x. Now for Desmos, you do actually just use the subtract as your negative symbol, where on a calculator you wouldn't do that, but this is smart enough to know. Hopefully that'll work. And then plus your 1, and then make sure you close that off. So you have to hit that absolute value of a symbol again. Then I'm going to subtract 4. So if you're coming out with errors and things, make sure you actually did the other end of it. And that's going to give me this one graph here. You can see with the V. That's my absolute value, represented by this expression there, 3 absolute value negative 2x plus 1 minus 4. So we want to see where that equals 11. So now we're going to actually make another graph. So we're doing this like a system. So we're going to graph the constant 11 and see where the two intersect. Now we don't see anything happen, so it's because our scale is way too big. So we're just going to go ahead and shrink it down. Okay, so one thing I didn't write in here, which is okay if you're just doing one graph, but if you're doing two things that you want to show intersect, you have to have them set equal to each other. So here I wrote y equals 3 absolute value negative 2x plus 1 absolute value and absolute value minus 4 is what I typed in there. And then for the constant function, I also have to type in y equals, so it knows that I want to see where they intersect. And so I'm going to make this scale just a little bit bigger. Another way. And we can see that point of intersection is the point where x is 3 and this one is negative 2. So that's one way you can check your answers. Of course, I want to see the steps written up on a test or whatever, but you can use calculator tools and be checking things for that purpose. So especially when you are going into pre-calc and calc, you're going to be dealing predominantly with the graphs of these, especially when there's inequalities. So I want to make sure you have that good skill for that. You can graph them out by hand later in pre-calc. You learn transformations. You may have learned that along the way somewhere, but also already. But you can sketch graphs pretty quickly by hand, but technology is generally allowed in most classes, but you would probably have to bring in a graphing calculator. But Desmos for homework is really great. So let me know if you have any questions on these. You'll work through some homeworks. I'm going to do the inequalities one in a separate video. So have a great day.